are going to write down everything that is wrong with this table as far as normalization is concerned. Not as far as the requirements or addresses or phone numbers or anything. Just the structure of the table. This is not a test. Awesome. All right, so somebody want to give me a hint? What's wrong with this table? Yes?
Requirements has multiple values in some places.
Requirements have multiple values.
Like
What's wrong with that?
Like Math 101, Math 102, it can be split into its own table.
So like requirements and major. So, but like what is the problem? Like what is the problem with having multiple requirements? Like why is that a bad thing?
It violates one of the normal forms.
So if I were going to use data, what could go wrong? Why we're interested in why.
It wouldn't know which one you were trying to.
Okay. You could do what, sorry?
We could write it in a different order, but it's the same thing.
Exactly. So if you look at the math major here, calculus, algebra, geometry, math 101, 102, 102, they might be the same thing. That's not a good thing. So we're saying break out requirements into a separate table. Is there another thing that you can think of just particular to the requirements table? Why it's bad, why it shouldn't be in this, the requirements column, why should it not be in this particular table?
Because it has more to do with the major than the student.
Exactly, right? What is this table about? Students, right? Are the requirements related to a specific student? Is there like a one-to-one relationship? If I am Carter Smith, am I required to take physics and chemistry? Is this somehow related to me as a person? Not really, it's related to my major. Right? So that's another reason to break out into a separate table is this table seems to be mostly about students, whereas this is mostly about majors. It's a completely different topic. Right? So logically, it should be somewhere else. What's another problem with this table?
In the average grade column, it looks like someone was trying to enter 100, but they entered 1,000, so it seems like there should be some rules maybe for what values can go in there.
Okay. Any other suggestions on how to fix the average grade?
Just
Remove a zero? Yes! I got 100. What if it's 10?
Yeah.
What if it's 1?
If you try to look up the grades from like 50 to 100%, you're not going to find her grade because it's outside the parameters.
Let me phrase it a different way. If you, as an example, were designing a database to hold student data, yes?
You can have certain triggers where they automatically flag any values outside of a certain range.
You could do that. What else could you do with average grade?
You can just have it be a calculated entry where it looks at it looks at the student's just class list.
I would take it even a step farther. Why do you need a calculated grade?
You just make it the value, make it an A, B.
Why not just get rid of it? Right? This is just asking for errors, right? If you're storing all their grades anyway with their classes or whatever it is, why do you need to recalculate it into some other place and store it separate from that? If I want to know their average grade, I'm going to look up all their classes and average it. It's not a very expensive operation, right? So calculated columns, and again, I'm going to put an asterisk beside it because we'll learn later on that there are cases where we want it. But in general, right, databases are supposed to store data. They're not supposed to calculate data. right? Asterisk, right, with some exceptions. But like, there's no reason to duplicate all the data you have somewhere else stored. And then, you know, a teacher says, oh, somebody handed something in. Now I have to make sure that this gets automatically recalculated, you know, or somebody updates it manually and puts in a big error. Then I got to figure out what's going on. So this just, it seems like a bad idea, right? Average grade just seems like a bad idea. What else?
Phone numbers aren't all in the same format.
Ooh, good. Phone numbers. That's a hard problem. How should we do phone numbers? Just the number. So, phone numbers. Here we go. Options for phone numbers. Phone numbers. So you're saying basically stored as an integer.
Yes.
Integer. Pluses, minuses. Good idea, bad idea?
Well, it means like some area codes are like plus 44 for like Europe.
Oh. International numbers. Haha. Right? International code column. Should we have more columns? I can spell column. I'm going to do the like. You know what I mean.
Make it more abstract.
Exactly. This is why I type. So we have, you know, are we going to have other international phone, US phone? What if I want to search by everybody in my area code? Should I have a separate column for area code? And then number? Should I have a separate column for country code? Then area code? Like, what is the catchphrase for this course?
It depends.
Right? How are you going to use the data is the big question here. So this is, phone numbers are always a problem, right? Putting down an integer is a common way to do it. Storing it as just a big text is one way to do it. You can just say, that's a developer problem, right? I'm going to store it as a text, and it's up to you to figure out. I'm not going to enforce it, right? I'm just going to store it as a big string. It's up to you to deal with it. That's perfectly fine. As long as it's documented somewhere, right? As long as you're not just assuming they're going to do something. Yeah?
When you are putting together a database,
Yeah.
they have like a date format.
Mm-hmm.
Do they have something like that, or can you find that easily with some rather than others?
The short answer is I would not expect a database to have a phone number format. Because the nice thing about dates is you can always have a starting point, right? Like you can say, most Unix computers, for example, the time starts 1970 January 1st at midnight. And so when it stores a date, it doesn't actually store January 21st, 2020. It stores the number of seconds since 1970 January 1st at midnight, and then it computes it for you depending on your time zone and all this stuff. So the way they've done it in the background is really nice, whereas with phone numbers, there's not really anything like that. There's no way to be consistent with phone numbers. You know, if you are a local, you know, one-person food delivery place, right, you can pretty much assume that you're only going to have US phone numbers. That's a reasonable assumption, right? And by the time you become an international megastar of, you know, yeah, fooddelivery.com, whatever. You know, at that point, you can hire other people to figure out, you know, this phone number stuff for you because you're not going to be using the same database. You're going to have to expand. So bottom line, it depends. All right, enough about phone numbers. What else? Don't see a primary key. Very good point. What do you mean by that? Whoa. That means I've spent too long on this slide. That's what that means. Right, yeah, absolutely, right? What if, you know, I have 2 Carter Smiths? That's, you know, that's pretty common, right? There's no student ID, there's no email, there's nothing I can use as a primary key. So again, what should I use? Should I use the student's email? You would create one. How would you do it? Giant integer? Giant integer? It does not only depend how many students. What does it depend on? How many students? Ever. Right? So luckily there is something in computer science called a guaranteed unique ID, which is 0 to 9, A to Z, I think, something like that. I'm not sure if it's capitals and lowercase. So basically you have like at least 36 characters times, I don't remember how long the string is, or not times, to the power of, say it's like 20 characters long, right? So that means to the power of, right? So 36 for the first character, 36 times, you don't have to write this down. I'm just explaining how you can guarantee that something is unique. You randomly take 20 characters from this subset of characters. So each one can have 36, or if you take capital and lowercase, right, you can have 62. 62 for the first one, times 62 possibilities for the second one, times 62 for the third one, times 60. So by the time you get 20 characters long, that's more than the grains of sand on Earth, right? If you try to type in 62 to the power of 20 into Google, it will not give you an answer. Wolfram Alpha might, but Google won't. Right? So that's an insanely large number. So you could do that, right? There are algorithms to come up with guaranteed unique IDs that will never conflict. What do you guys use?
Stinger ID.
What was it called? Yeah.
You mean like here?
Yeah.
Like your college, they give you an ID.
Yeah. Right? So there's some ID that Winona gives you, which is A to Z, 0 to 9, 0 to 9, 0 to 9, 0 to 9, A to Z, right? That format. So you could, those are unique, and I think the way that they make sure those are unique is they just search the database of all students and make sure that they're unique when they add somebody new, right? They have some algorithm that does that, right? That is totally fine. That makes it easy to remember, right? Imagine that your student ID was 20 random characters long and you had to type that in every time, right? I would actually guess that at Winona, in the big database that holds all of your information, they actually have both, right? A guaranteed unique ID and one of these, but this is the only thing you see. But anyway, so that would make things better, having a primary key over here, something that is unique to you. Anything else that bothers you?
Advisor column.
What about the advisor?
Well, you have Mr., you have Professor, John.
It's the same as the phone number. It's different formats for the same.
It's for the same information.
And
Misspellings, right? So obviously somebody's been typing this in by hand. Nobody has ever misspelled my surname, so it's kind of a, fake example, but advisor column, what should we do with it?
Create another database or a table and have it linked via the form.
Exactly, right? Does the advisor name really have anything to do with a student? Not really, right? It's more like the idea of an advisor, right? Where the details about that advisor should be somewhere else. Anything else?
in the major column, there's CS and also computer science.
All right, same problem. You have duplicate information written a different way. Again, it's the idea of a major should probably be somewhere else. It doesn't really have anything to do with this student, this particular student's personal information. I mean, there's other things you can nitpick too, right? Like what if I wanted to search by zip code? It'd be kind of hard, right? Could be. Do you need to? Maybe, maybe not. I don't know. It depends, right? One thing that you're going to find as you start designing databases is everything's a trade-off, right? Like you cannot, if you're designing a database for a local one-person food truck, right? You should not add 1 million lines of code to deal with international phone numbers. You should not. That is bad, right? Because you're spending your resources on a very, very, very small, tiny use case, right? You should be doing the most for the most in databases, right? You should be trying to make it as generic as possible, but not so generic that you end up with a pile of spaghetti that is unmaintainable, right? So it's this balance. It depends on what your use case is. It depends on both what you're putting in the database and what you're trying to get out. So, all right, so let's go through this in a little more formal detail. First normal, again, you want to break things down into logical pieces. And like I just said, not too much. Logical is just as important as pieces, right? So most of these columns have nothing to do with the student, as we talked about, right? So a logical piece would be major, right? Have a table about majors, put the requirements in the major table, right? Put the average grade in the garbage, in my opinion, but if you need an average grade, maybe when people graduate, right, you want to store a GPA or something, the final GPA that never gets changed, right? You could do something like that, but I would get rid of it. It doesn't make sense to me, right? Address we talked about. If it's the person's home address, then it belongs in this table because it is unique to that person, right? We don't want to break up this into a separate addresses table because, again, you're just adding complexity for no reason, right? And you wouldn't break this up into a separate zip codes table out of the address. Like, you can break things up as much as you want, but, again, you have to, why am I doing this, right? You have to have a logical reason to do it. Phone number has to do with a student, keep it in here. An advisor, maybe it's part of the major, maybe it's separate, I don't know, but it doesn't really belong. Their name does not belong in this, right? You want to have like a professor ID or something, advisor ID, and then you'd have a professor's table or something like that. Identifiers must be unique, so I don't remember who said it, but somebody said we don't have a unique identifier here, and that's absolutely correct, right? You want to have a way, or you want to try to make it so it's impossible to have multiple ways of saying the same thing. So things like this, right? Math 101, 102, 103, Math, CS, you don't want to have that, right? You want to break that out and make it so that it is unique. So we have major ID. Math major ID might be ID number 456, and in that table you have this listed once. You don't have it multiple times. So if you can remove the possibility of doing that, remove the possibility of doing this, right, you are saving yourself headaches in the long run and your users. So that's first normal. Second normal means, again, it needs to depend solely on the primary key. So that's what we were talking about just now. Requirements have nothing to do with the student, right? This table does not follow second normal form, right? There's a bunch of information here that has nothing to do with our primary key, which is the student ID. TLDR, don't try and say two things with the same table, right? Don't try and say who the person is and what the requirements for their major are. Simple way to remember second normal. Right? Say one thing with each table. Logical breakup. Third normal, number one, no calculated fields. Again, it's error prone. So the caveat to this is I used to work years and years ago in an industry where we would go through about, just my group of 15 people would go through about a terabyte of data a day, right? And so we would calculate our profit and loss based on that terabyte of data. So you can imagine after a week, you have 5 terabytes of data. After a month, you have 28 whatever terabytes of data, right? You don't want to have to go through that every time. Like if this is a financial company, right, your profit and loss is never going to change for like once the day is over. Yeah, you might occasionally have to go in and fix something. Oh, I typed in a trade wrong or whatever. But like, for example, at the end of the year, you want to have your server go through and calculate your profit and loss for the entire year, right? And then put it, put it in one annual profit and loss, right? And you'd put in a year, 2019, department number 50, and profit and loss $1 million, whatever, right? Because this is what's called write once, read many, right? I never have to go back after January 31st of 2019. This is never going to change again, right? It's not like your GPA that changes every time you take a new course that somebody has to go in and type in and make sure they get right. I also don't want to have to go through 300 terabytes of data to calculate this every time somebody's like, oh, I wonder what the profit and loss was for this group last year. So in this particular use case, right, on midnight of January 31st, I go through, I have my server calculate this. It takes a couple hours, whatever. It comes up with a number. I stick it in there, and I can use it forever. Maybe I have to go in once a year and fix something, and I have to recalculate it, but I'm not doing it every time. I'm not doing it every week, every time a student gets a new grade, right? Once 2019 is done, it's done. So I can create all sorts of reports. I don't know if any of you have ever used financial software. Like if you have if you've started, or if you have a student with a 529 plan or something at like Vanguard or something, they have like monthly, weekly, all these kind of reports you can see with graphs, blah, 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 right? They're not recalculating it every time you look at it, right? If your 529 plan for college went up 10% last year, that's never changing. It went up 10% last year. Every time you look at it, right, it's the same. So in this use case, there are use cases where you can have a calculated, but they're very specific, right? So in this case, bad idea, because every time I type something in, your average grade changes. Every time you submit something to me, that's a bad thing to have to go through and recalculate everything. In this use case, I would rather, or you would rather know your average grade accurately based on what's in D2L. So it'll just calculate it on the fly, because there's only, what, like, at most 200 rows? If you've taken a couple classes this year. So anyway, so that is an exception for calculated fields. Duplicate fields, this is a quotation I found. Oh, by the way, some of you that are here, I was looking at the normal forms for Wikipedia, on Wikipedia. They're actually really good. So if you want to, like I'm not a huge advocate of using Wikipedia all the time, but in this case, the normal forms, the descriptions are really good if you want to use them as a reference. Anyway, point being, that's where I got this quote, and I love this quote. Every non-key attribute must provide a fact about the key, the whole key, and nothing but the key, right? Have you guys ever talked about having multiple columns be your primary key? a little bit. So you can do that. It makes things a little more complicated, but anyway, the point being, we've kind of already covered all the individual parts of this, but must provide a fact about the key. So again, student is the key. Requirements does not provide a fact about the key. The whole key, right, means it has to be about the person, not just, about their advisor. And nothing but the key, so again, we should not be providing details about things that are not in our table. And then, obviously, having multiple, we already talked about having multiple items in a single column is not a good idea. So we're not going to get, I'm not going to use anything further than third normal form. I think that's what you guys did in your last class too, right? Did you go beyond third normal? So there's officially 6 normal forms plus all these other normal forms that other people have come up with. I'm sure you guys are going to want to read that on your Saturday night, but the bottom line, and again, I'm coming from a practical side because that's what this class is about, is remove as many error-making chances as possible. That is the whole point of this, right? You want your data to be, when you're using MySQL, this is going to change in the second half of this course when we do NoSQL, but for MySQL in particular, the whole purpose of MySQL was to be use agnostic. The whole point of MySQL is to say, I have data about an idea, about a single idea in a single table. So that's essentially first normal form, right? Or actually all the normal forms is, I have an idea about a student and only my student data goes in there. I have an idea about a major, only data about the major goes in there. So that when I look at the data, when I look at an ER diagram, I understand right away how to use this data and what each logical piece is. That's the point of normal forms. It's not just to annoy you. It's to remove as many error-making chances and to make it use agnostic. So that if you change the way, here's a perfect example, right? Until about 15 years ago, nobody had mobile apps, right? All this data, again, pick on Vanguard, was all based on individual apps, usually Java apps, right? Then the internet came along, all of a sudden I needed to use this data on the web. Completely different programming languages, completely different use cases. Oh, now we have mobile apps. Completely different programming languages, completely different uses. But the underlying data structure should be the same because the ideas of the data are the same. So that's what use agnostic means. It doesn't matter how I'm showing it or using it or updating it or whatever. If the data structure should match my ideas. So here's a slightly better students table. Right? Student ID, I just used integers. Right? This way, if I search for a last name Smith, right? In here, if I search for Carter, I don't know if it's their middle name, their last name. If I search for Smith, I don't know what I'm going to get. Right? So breaking it up into logical pieces. Again, major ID like you guys suggested. Address I still kept all together because why not? If that's my use case. And then advisor ID, right? Again, I'm going to break out into an advisor table. I still have, kind of a mess in my phone number, but does it really matter? Do you not understand this compared to this or this? If I select the phone number for Emily Carter, does it really matter if it has parentheses in it?
Less readable,
But
no.
yeah. But maybe it does, right? Maybe I'm making some robo-dialer that needs it in a certain format, oh, well, then all of a sudden my use cases have changed and I need to be a little more precise. But if this is my food truck with just my customer info so I can manually let them know when I'm having a sale, who cares, right? You have to think about it in a practical way. What about phone number? Let's talk about it. You guys are familiar with primary keys and foreign keys already, yes? So I can go over this pretty quickly. Yes, a lot of nodding, some people snoring. Excellent. So I just kind of broke this up, right? So this is not the primary key for the students. The primary key is their student ID. The primary key for a department, so the primary key in general is something that uniquely identifies something, right? That's what a primary key does. You can only have one student ID number one. You can only have one department ID number one. You can only have one faculty ID number one, right? So this foreign key means it matches somebody else's primary key. I cannot put a major ID in here of 528 unless there is a department 528, right? If I create a foreign key on this, MySQL will not let me do that. It will say foreign key error when I try to insert a major ID of 538 if there is no matching department. Same thing if I try to insert another department ID number 2. If I try to insert history with a department ID of number 2, it'll say, primary key error. So that's the way that all of these tables are linked up, right? Requirements for majors, a better way to do it is to just have 2 foreign keys. I don't have any data in there, right? Because I already have departments over here with the ideas about the departments, and I have the classes over here with the ideas about the classes. So all a requirement is a linking of 2 tables. Right? A requirement is nothing in and of itself. It is a linking of a department with a list of classes. I do not need any more information in here. Unless, right, things change over time and you need to keep track of that. Right? Maybe in 2020, the requirement for computer science are different than they were in 1970. Probably, right? So maybe I need years and stuff in here. Depends on your use case. Again, it depends. But this is a reasonable way to break down that horrible, horrible table I came up with in the first slide. So your assignment for Thursday, is to go into the production database, right? And basically, do this. I do not want you to copy this, right? I didn't give you the slide so you can copy it. I want you to come up with it your own way. I want you to click on, so you can, okay, so I should have had a slide about this. In the production database, every database that you create will have your ID first. So you are allowed to create any databases you want, but they will all start with your ID. So say my ID is AB1234CD, right? It'll be that underscore, I don't really care what you call it, maybe call it university or school or something like that, just so I know what the assignment is. So you're going to go into the website, create a new database called something like this, and then you're going to add, excuse me, you're going to add a students table, a staff table, a departments table, classes table, and a major requirements, and I want you to add the primary keys and the foreign keys. So you're going to have to make up some data. You don't need to put in a million rows. 3 or 4 rows in each table is fine. I just want to see that you know how to create the table, you know how to create some data, and you know how to create the keys. There's 2 ways to do it, actually, if you want to get fancy. In PHP MyAdmin, There's a SQL block, so you can actually learn how to type in the actual SQL commands to do all this if you want. Not required, but if you want to get really good at SQL, you can do that. So here are your IDs with your databases. So if one of you creates a new database, right, it'll look like this with an underscore. I don't see anybody that's done that quite yet, but anyway. That way I know whose is whose. So you can either do it right here in the GUI database, right? Create a new database. Don't worry about the collation. And then once you have a database, let's see if I'll just create one. All right, then you just create the tables in the GUI. So you can do it all in the GUI if you want. Or you can do it in SQL by typing in SQL commands if you want. Any questions? All right, ready to go. And I will post the assignment in about 5 minutes.